So we were discussing that in this system and this subject we have covered two parts. One was a requirement analysis, and second was the use case diagram. Okay, in requirement analysis we are trying to find what the client want, okay, or what should be the different components of the system, and that one is too general. There is no detail in that. For example, if an online system, if the client want that there should be a facility that the customer could return their products if there is any problem, but there is no detail how this process will be done. Okay, if someone want to return a item, so the process will start from where, what will be the steps of that, and how it will be ended. There is no details of that. Okay, so we go a little bit further and we try use case diagram. In use case diagram we simply try to functionally visualize different components of the system, but that one is also not that much detail from process point of view, that how it will work and how one process will be linked with another process. In a system all the processes are linked to each other to complete one task. So therefore the two parts, requirements analysis and use case diagram, cannot visualize the process. So today we are trying to discuss and study in very detail process modeling. Process modeling is also called data flow diagram. Okay, so what is it, how it works? Let's go and oh my gosh. Okay, these are the outlines. We will try to cover data flow diagram. Inside that, how to read the data flow diagram and what are the different elements of the data flow diagram, and using data flow diagram to define a business process. This is the main objective. Okay, and process description, and then finally we will try to create some data flow diagrams. We will practice something. So let's continue on. Okay, so first of all, what is a process model? Okay, or what is a data flow diagram? A process model can be used to further clarify. You see, as I told you at the beginning, it further clarify the requirements definition that we did through questionnaire, through interview, through discussion or observation. Okay, we want to extend the same thing to one further level. Okay, and another one, and the use cases. Okay, the use cases and the requirement analysis that we have done so far, we want to bring the same concept one level further and in much more detail to understand the behavioral or functional aspect of the system. A process model is a graphical way of representing how a business system should operate, meaning to say how it will work. Any process will start from which point, what will be the internal steps of that, okay, what are the details involved inside that process, okay, what will be the inputs of the process, what will be the processing in that, and what will be the output of that process. So all these detail, when you represent graphically, okay, this is called a process model, this is called data flow diagram, are the activity that the people do. So you see, in a system, actually there different people are doing different activity. So all these activities, how they occur and how they are interlinked to each other and how they affect one and another. Okay, a process model can be used to document the as is system. We have studied this word several times. Do you remember what does this mean? This is a quite famous terminology, as is system.
The current existing system.
Exactly, very good. The current existing system. Okay, so uh, how to know that one first, and to visualize that existing system first. One way, it is also possible that we use data flow diagram for the existing one, and it is also possible that we design, mostly it will be about the 2B system. The 2B system is the new one which will replace the existing one. Okay, so we are trying to visualize, we are trying to graphically represent the whole system, and then the subsystem inside the whole system. Okay, meaning to say we will decompose the whole system into sub processes, and then we will interlink the sub processes to each other to complete one task. Okay, so how to do this? Let's go ahead. So data flow diagramming is a technique that diagrams the business process. And note the point, I highlighted the word data. You see, the business process and the data that flow, that passes among them, are the data which flow from one place to another place. Okay, let's suppose a data is A. Okay, it has some value, it enters to some process. Okay, something will happen here, and the A will change to some other format. Okay, then it will go out as a output, or it maybe it will go to another process, it will enter to another process. So the whole process we will show, but the main focus here is on the data. Okay, this is why it is called data flow diagram, how the data flows. Okay, and a logical process model that describes the processes without suggesting how they are conducted. Okay, so there will be not too much detail about this, that how to conduct this, but what the process is, what are the details of that, we will talk about that. Okay, and the physical process model provide information that is needed to build the system. So what are the different processes which will finally complete the whole system? Okay, this is just example, don't worry if you don't understand at this point. We will talk about a lot about this. Okay, and all these details, and especially the same diagram, we will talk about again and again. Okay, I am briefly explaining. Okay, if anything is not clear, you just wait, details are coming behind. Okay, so you see, it is something like this, that a person that we have, you see, this case study, we already know about that a LAN chemical applicator is selling pesticides, and different people are purchasing pesticide from it, and the people are ordering. Okay, and then the LAN chemical applicator checks and validate the person first, and if the person is valid, then check the quantity, then check the pesticide, that is this pesticide is available. If available, then how much is available, then checks that how much the customer demands and how much quantity we have. So all these processes, how to visualize until the delivery point. Okay, just general one. So if you look from the, mostly data flow diagrams start from left to right when you are reading, left to right or top to bottom. Okay, so the LAN chemical applicator, you see, it a chemical is needed. You see, from here, a chemical is needed. Then determine chemical approval status, meaning to say that the person who is looking for the chemical, is it authorized, and second, the chemical is also authorized, it is allowed to sell and it is available. So this is a process. Okay, don't worry the diagramming, the naming, the coloring, we will go into much detail. Okay. Sorry. After that, when this status is approved, then you see the approved chemical, so this status will go to next level, that yes, this chemical is approved. One thing. Another one, you see, if let's suppose the chemical is not approved, so you see a return message will come back that unapproved. If unapproved, the process will stop here. If approved, then it will go to the next level. And in a next level, you see, determine request quantity, how much the customer want. And you see this quantity, how the system will determine. You see, from the right, information is coming from the databases. This is database. I will explain to you later on, don't worry. Okay, we will go into much detail. So this is just a general general diagram. Okay, later on we will go in much more detail. Okay, so it works like this. Don't worry, I am not going into my detail because I think you will be confused. So first you should have a bit background of the fundamentals, the diagrams, the naming of that. Okay, and then we will do that. Okay, so next one, process. A process is an activity, like for example registering to a course, this is activity. Searching a product, this is activity. Okay, anything else, any example? Can you give me any example of any activity? Hello guys. Oh, still thinking. Okay, login is activity, sign up is another activity. Okay, log out is another activity, payment is another activity. Okay, all these are different processes in some system. Okay, so it's an activity or function performed for some specific business reason. Not the point that these slides will use too much the word business. Okay, and I explained to you several times that our target is two-way. One may be business and one may be service. Okay, one may be business and another may be service. So for the service point of view, it will be not like business reason. Like for example, when you want to log into eLib, then selecting a specific subject, this is another activity. Okay, then participating in some activity inside the inside that subject. For example, if there is a quiz inside that, how to conduct that, then how to submit it, how to see your score, all this stuff. Okay, or maybe if you want to resubmit, all these things are possible or not, and how to do it, and to show diagrammatically, all these are processes. Okay, so process is nothing, it's an activity, it is a function to do something. Okay, so if it is activity, if it is action related thing, then you see, look at this, every process should be named starting with very important keyword, starting with verb. Why? Because verb show action, like login, okay, search, okay, purchase, pay, okay, and so on. So it will start with verb and will end with noun. and performs only one activity. In one process will be one activity. If you combine another one, then the concept mix together and is not clear. Therefore you will not use the word and. Never use the word and. When you are naming a process, you will give the name uh, starting from verb, okay, and ending with noun, and never use and. How? Let's just go back to the slide. You see, all the numbers 2.1, 2.2, 2.3, 2.4, 2.5, these are processes. Okay, don't worry, later on we will study in detail, but just look at the name. You see, determine is a verb and status is a noun. Determine, okay, and quantity. Update is a verb, prepare is a verb, confirm is a verb, request is a noun. Is it clear somehow? Hello? Okay, good. So yeah, you try to understand like this. So if any confusion, you can stop me. And I really expect from you that you try to understand from now, not like this, that this time you just ignore, and when assignment time comes in, then you will have to do, and then you need to learn, and at that time you try to learn what is it. Okay, and at that time of course I cannot respond to individual student. Okay, sorry for that. Okay, another one. Every process must have at least one input data flow and at least one output data flow. You see, a process cannot start without any input. Okay, for example, order processing. Okay, the order processing, you cannot process the order unless someone order first. Someone will order first, you will receive the order as a input, then the process will be order processing task. Okay, otherwise, okay, is impossible. It is something like this, that without any input actually no system can work. Okay, there is no such system in the whole world which work without input. Or do you think is possible?
No.
Yeah, it is not possible. There is no system in the world which works without input. So if it is true, then there should not be any process without input. There must be input to a process. And note the point, this is quite common mistake when you are designing data flow diagram. Later on you will realize this. Okay, one thing. Another thing, if there is no output, okay, output is the goal that we want. Okay, if there is no goal, no output, so the process is actually useless. It is meaningless, right? Okay,
Yeah, yeah.
so meaning to say, every process must have at least one, it may be more. Okay, it may be more inputs, but at least one input is very necessary. If there is no input, the whole diagram is wrong. Okay, and if there is no output, the whole diagram is wrong again, because without output, why we are doing the process? Okay, it is useless, it is waste of time, waste of resources. Okay, this is about process. Okay, next thing which is part of this diagram is data flow. Okay, data flow mostly we show by the arrow. Okay, by arrow, and that arrow show something is moving from one place to another. So what is moving, that should be labeled here. What is going from one level or one place to another place, Okay, so that should be label here. Let's suppose A. I'm just giving A, but there will be a proper label. Okay, you can do like this also. We will see example. So a data flow is a single piece of data. Note the point, single piece of data. It is not possible that you show by one arrow that A, B, and let's suppose C, all these are moving together. No, you will have this concept is wrong. Only one piece of data, you see, single piece of data are logical collection of several pieces. But logical collection, okay, logical collection, maybe if you can't understand, just focus on this, that only single piece of data, it will flow from one place to another. So you see, now again, what are the rules for that? That every data flow should be named with a noun. Note the difference. Process is verb, data is noun. Okay, and the data flow are the glue that holds the process together. You see, the data moves from one process to another, and when move from one to another, actually the two processes are joined together by this arrow and by this data flow link. Okay, one thing. Another one end of every data flow will always come from or go to a process. So meaning to say that the data flow will must pass by, okay, through a process. For example, like this. Okay, let me show you just a quickly. Later on I will show you the diagram also. Let's suppose this is the process, okay, that we show. Mostly we show process like this. Okay, it is diagram is like this. Here is a name of the process. Here is a bit description of the process. Okay, so this is a data coming to, so the data must come through the process. It should not be like this, that okay, the data just go over the process and go directly to output level. No, it is not possible that input directly become output, okay, without any processing. Are you agree with this? Is it understandable? Okay, good. So input cannot become output without any processing. So the input will be processed first and then will become an output. So for the processing purpose, the input must go through the process. And here will be some processing inside. Let me show you the diagram once again. So you see, this one is the data flow. You see, this data flow goes through this process and then go as a output in some way. So it is not possible, you see, that it directly go from here and come to this place. No, it go through some process, and after this process it go to next level. You see, and then from here, from this process, you see, like this information, you see, this information comes through this process and then go to the person. So this is a data, okay, but this data is coming from a process. This one is going to a process. So data must be go to or come from a process. Okay, so this is another. Okay, next component. these are the different components of data flow diagram. One is process, another is data, third one is data store. Data store is what? It is a collection of data. Okay, a collection of data that is stored in some way. So collection of data is actually like a database. Okay, like a database. And database is what? It is actually, it may be collection of information, it may be collection of items, but it is a group of a bundle of a lot of information stored at one place. Okay, then the data store form the starting point of the data model. Okay, sometimes it creates the starting point of the data model. At least you see again one input and one output data flow. It means that if let's suppose this is a data store. Okay, so this data, if you are storing, how it will be stored, some input will come to this, then the data can store. Okay, one way, meaning to say the data cannot be stored without coming something to it. Okay, one point. Another point, if we are storing a lot of information, then why we are storing? We should use it, and you can use if something is going out from it. Okay, if something is not coming out, some information is not coming out to us, then why we are storing? It is again useless. Okay, so there should be data flow to the store and to the store and from the store. And another thing, the data flow that stores data and the data flow that receives data should always be shown as a two separate data flows. Note this point. It means that if data is going into the data flow or into the process, okay, that will be a separate arrow, and the coming out will be a separate arrow. You cannot do like this. You see that you use an arrow that it is going in and this one is coming out. By one arrow you show both things. No, according to data flow diagram rules, it is wrong. If you want like this, this will be the to, and this will be the from. And you see why it is like this, because every data has a name. So this should be clearly differentiated, what is going in and what is coming out. And if you use one arrow, then it is difficult to differentiate what is going in and what is going out. So if I write, let's suppose here A, so and the arrow is double headed, so the A is going there or A is coming out, it is not clear. So this is wrong because of this confusion. Okay, you see the main objective is that why we are doing all this process, the requirement analysis, the use case diagram, the feasibility, and this data flow diagram. We want that we should understand the existing system and the new system in much more details. So for understanding purpose, this every step should be clear. It should not create a confusion, otherwise the whole objective is getting lost. So I hope you understand what is data store, right? Hello.
Yes.
Okay, good. Can anyone tell me in your own words what is data store? Don't look at the slide definition. In your own words, anyone? Hello. Yes, start. Don't shy. No problem. This is just discussion.
It is a database where like the data is stored there. and like it is used, and how do I say, you must have input and output for a data store, because you need to use it and you need to store something in it before you can use it.
Exactly, true, very good. Yeah, it's a database. It's mostly data store is used for information process. Okay. Otherwise, you see, look at this diagram. The diagram will be quite clear to you once again. You see here, the land chemical supply, you see the supply, this is a data store. This supply warehouse, or you can say warehouse, or you can say like a store, this know the amount and the availability of the chemical. So this is why you see the confirmation comes from here. Quantity available, how much is available. Okay, so this information is actually here. Okay. Next one. Next one is external entity. External entity is in a use case diagram. If you remember, it is the actor. Okay, actor. It may be a person. It may be some system. It may be another activity which initiate the process. Okay, or which send some input. Okay, it may initiate the process, it may send some input. So anything which is outside the system, external to the system, not part of the system. Note the point, the data store, the data and the process, these three things are part of the system. These are inside the system. This one, external entity or the actor, they are outside the system. But these are actually the initiator. They initiate the process. Okay, next one. Okay, so now we are going to much more detail, that if we want to represent a process, how to represent, which diagram we will use, how we will name it. If we want to show data, how to say. If we want to show data store and entity. You see, there are only four things that you should learn. The whole chapter, in the whole process, you need only four things. What are the four things? This four entity. One is, this is one, the process. This one, two, the data. This one is third, the data store. And this one is the actor, the external entity. Okay, external. I will, four. Yeah, is the external entity. Okay, so there are several different systems in the world and several different point of view. For example, engineering people think a bit differently, business people think a bit differently, IT people think a bit differently. So therefore there is a slight differences between the diagrams and between the names. But what we are using, we are using this system, data flow diagram. Okay, we are not using the software engineering system. But if you want to have a look, it is better, because maybe sometime you will see in a tutorial. Okay, maybe the tutorial is made by engineering person, or maybe some books. Okay, so this is these are the two symbol system. One is the gain and Sarsen symbol, and one is the demarco symbols. Okay, so we are not using this one. We will use the gain and Sarsen symbols. Okay, to show a process, we will use this round corner rectangle. Okay, and it is again divided into two parts. The first part, the top, is the number. Every process has a number, like 1 or 0 or 1.1. Okay, and the lower part will be the name. So if you see here, every process has a number, and the number will be here. Okay, and a name, this is a name, and the name will be a verb phrase, like purchase, update, confirm, search, okay, and so on. And it may have description also. Sometimes some people put description, some people don't put description. It's up to you. This is why it may have a description also. Because sometimes the diagram is smaller and you cannot put too much text in that, then people skip it, okay. And if there is if the name is not so clear, so you can put and you should put the description also. And usually one or more input data. So process, as we discussed, process cannot start without any input. There must be some input to it, and the input mostly comes from left or come from top. This is a general practice, okay. It can go from bottom also, okay. It can go from right also. Generally it is like this. So process, the diagram, its properties should be okay, huh? Any confusion to anyone? Hello?
No.
Okay, good. Let's come to the next one. This one is data. We represent data flow by arrow, and this arrow has a name, and you see this arrow must be one directional, okay, single directional. It should not be a double directional like this. No, it is wrong. Why? Because it has a name, and if it is bidirectional, then the name is confusing. That the name is input, it is going in or it is coming out, so it is confusion. And another very important point, that its name will be a noun, okay, like quantity, product, okay, offer, order, okay, all these are nouns. And it may have description also, and one or more connection to a process. It will must connect to a process, otherwise where it goes, for what purpose it goes, okay, then the movement of the data is useless if it is not going for some processing, or if it is not coming from some processing, then it is just useless, a useless movement, okay. Another one is a data store, okay. Data store mostly we represent by the character D, and if it is the first data store, then D1. If second one, then will be D2. Third one will be D3, and here will be the name of the data store. So it has a number, it has a name, so its name is also a noun. It may be description, and one or more input data flow, and usually one or more output data flow. If no data comes in, then is it possible to store information? Information should come first to store. If no information is coming, how the information will store? One point. This is why it must have input to the data store. Another point, if we store the information, so why we are storing? It must be used somewhere. This is then will be the useful usage of this information. If we are not using this information, meaning to say, if this information doesn't go to other process, okay, to support something, then the storing of this process is useless. And if you think from IT computer point of view, you see storage of information is what? It is memory, right? And memory is a very expensive resource of a system. So if you are storing information without any purpose, then you are just wasting your memory, right? And not only memory, the storing, the process, and writing data to there, it is a process. So even the processing power, the memory, all these things are useless. And the last component is the external entity. Okay, external entity has a name. It is also a noun because it is an actor. It is a person. Okay, person is mostly a noun, or it may be a system. Okay, or it may be some other system or other organization also possible. Okay, so these are the four components that it creates the complex. You can actually create as much complex system only from these four ingredients. Okay, from these four ingredients we can represent many complex different type of systems. Okay, we are going into details. If any confusion here, you should ask a question. Any confusion? I am giving you assignment and quick task. Okay, you should try to understand. No question?
Sir, about the data flow diagram,
Hmm.
uh, so which mean we can use either both of the symbol or we have to use based on the name.
No, no, I didn't get. If both of the symbol, you mean that we will use this symbol set or this symbol set. If your question is like this, then we are not using this one. Okay, you see the data showing here, here is a D1 and here is a different style of D1. Okay, here is a bit different. Here is like what is called it, like oval style, and here is a rounded rectangle. Okay, if your question is like this, then we are using this one. If your question is like this, that you see one is diagram like this, let's suppose. Okay, this is a diagram, one thing. Another thing, it has a name like purchase. Okay, purchase. So we will use both. We will use the diagram plus the name inside the diagram. So we will use both. Your question is like this?
Yes, sir. Okay.
Okay, good, very good question. If any confusion like this, please try to clarify now. Clear?
Yes, sir.
Okay, let's go ahead. Now we are going towards the system. So if the system is a quite complex system, like you can think of, let's suppose Shopee, Lazada, you can think of your elib, how many different processes are there. Then you will have to decompose the complex system, okay, into many subsystem first. For example, let's suppose elib. First of all, you say that okay, let's describe the login system first. So login will be one process, okay, and you will have to diagrammatically show all the login steps and the input and output to the login. So this will be one part when you decompose it. After that, maybe the two roles, okay, that one is student, one is lecturer. Okay, how will be this, how will be this? Okay, another part. Then again, for lecturer there are so many issues, like quiz, how to design a quiz, how to design assignment, how to design choices, discussion, label, the databases, how to upload a file. Okay, so you see this is one process, this is another process, so you will have to decompose into too many details. Okay, because diagrammatically if you are showing the complex system, then it will be very messy. The arrows will go over each other. Okay, because we cannot show on one screen or one page so many things. So the best way to decompose it into small processes. This is why we are giving numbers to the process, and the numbering show its order. Like, let's suppose in this case the login is number 1, and then after that the roles are number 2, and so on, then 3, then 4. So you see, this is a logical numbering which show the sequence of the whole system, and later on it is easy to rejoin all the processes to make the whole system again. Okay, so how to do that? For this decomposition there is a rule. Okay, this is, again, you see, I will, don't worry about this diagram also, we will do this one in much more detail. But if you look at this, you see there are 4 different levels. Okay, and this is the topic of today also. One level is context diagram. Note the point, we will do this one. I will give you assignment also. So this is the very first level of any system, and this one is very general. Okay, I think let's go to the slides, and then I will come back, go and you see, like this, that the first DFD in every business process is the context diagram. Okay, what is context diagram? The top level, this level only, you see, this level only is called context diagram. So you see, what is it? Okay, what is it? It shows the entire system in context with its environment. So meaning to say, it's actually describes very generally the whole system. For example, let's suppose Shopee. So if you want to describe the Shopee in a very general format, then you can say an online system where user can buy products. You see, online system where user can buy products. We are not talking about this, that how the user will buy a product. We are not talking about this, that before buying you must be registered, you must link your account with that, you should have a pay system, there will be a searching, there will be many things. So you see, we are not talking about this, we are just describing in very general. And you see, environment is also included, like online system where customer can buy products. Okay, so it shows the entire system in context. Okay, this is why it is called as context. So when I use the word online, actually it shows the context of the system. The system resides where, okay, how it will work. So from the word online, it is quite clear to us how it will work. If you are talking about ELIP, okay, then in ELIP we will say that it is a learning management system. So you see, the learning management system show that it is actually some university or college or school system. Okay, it is not a business process. So this is why it show a context also. The context diagram show the overall business process just as one process. Note the point, I highlighted this. Like you see, in Shopee case, like one process, purchase a product online. So you see, it's look like one process, but actually this process by itself has many processes. For example, I cannot purchase unless I register. So registration is one process, then login is another process, then payment is another process, searching inside that is another process, returning maybe another process. Okay, but in a context diagram, I say I represent the whole system as one process. Should be okay. Hello guys, should be okay.
Yeah, it's okay.
let's go to the diagram now, then you will understand. You see, in this case, this part is called uh, context diagram. Okay, so you see, quite general that entity A start the activity, and this is the information system. Okay, and like a person ask from the information system, and the information system get some information from its database. Okay, and on the basis of that database it gives a reply. Like from the system, ask something and the system will give. So you can say like getting information online or getting information from a system. So you see, actually this getting information from a system, it is not so easy and it is not so simple. Okay, it has many sub processes, but at context diagram level we show the whole process as one. Okay, like for example, in case of elip, okay, a teacher, a lecturer share information with student. So you see, a system where lecturer and student can share information with each other. So you see, it looks like a one sharing process, but actually it is not one process. The sharing again has many details, right? Hello guys.
Yes.
Okay, then another one rule that you will show is a one process. Another rule that context diagram will always have a number 0. Note this point. Context diagram will always have a number 0, and context diagram will always have some input and some output, and it may have maybe one or two entity involved. So this entity may be a person, this entity may be another system. So you see, at least one input, one output, at least one entity. Okay, this must be involved. Okay, so if I ask you that draw a context diagram for elip, go to this link. Okay, all of you go to this link. This is here. Oh my god, let's clear the page. Okay, you try to come here. I have already invited you. Yeah, you see. Okay, so how to draw? If you don't want to join, okay, everyone try here. I want to see. Try to draw. You see, here are the contents you can get from here. You try to draw. Wow, a collaborative system. All of you can work together. It's quite nice. Let's see it is working or not. You can see some drawing. I can't see any drawing. I'm just yeah, here I saw some drawing. Hello guys, is it working? You can see something? I think it is not good. I don't know from your end, so you should use the last link that I sent to you in the chat. Okay, this one is is much better, I think. You see here, it is this system that I sent to you. It already has many different how to say shapes, and it has some already template. It follow the same, somehow the same styling. You see the data store is the same diagramming, okay, the arrow the same, the process the same, the external entity, so it follow the data flow diagramming. I didn't get, what are you asking? So we choose the data flow diagram. Yes, choose the data flow diagram. Then the symbols and the options for you will be exactly the same that we are looking for. This one is, I think, the best.
Yeah,
But this one
much
is
more easy.
This one is better, right?
yeah.
Okay, so you quickly draw, and after that save it as a file. Okay, you can use the extract. Okay, after that upload to elip. In a elip, here I have created a link, you see, context diagram. Okay, let's see. I want to quickly see that do you really understand what we discuss? We just discussed context diagram. So context diagram is a general level description of the whole system, and the whole system is shown as one process. This is the keyword, as one process, and it will have the number, always the number will be 0. Okay, so that is context diagram. After that is a level 1 diagram. Okay, so what is a level 1 diagram? The level 1 diagram shows all the major, notice the point, this is another keyword, all the major high level processes of the system and how they are interrelated. So you see, again we are not going in too much detail, we are again just going one level deeper, and the major high level processes. Okay, and the level 0 diagram, the level 0 diagram shows all the processes at the first level, okay, the data storage, external entities, and data flow among them. So it will be a very beginner level, but the one process that we shown in a context diagram, the whole system we shown as a one process. In a level 0 diagram, we decompose the one process into 1, 2, 3, yeah, 1, 2, 3, or 4, it depends on you. But again, these three processes, this is one process, this is one process, okay, we will decompose like this. So this, the top level is context diagram, where it is one process. The next level decomposition is called level 0 diagram. Okay, but these three processes are also somehow quite general. Okay, quite general processes, and general means that each of these process actually has sub processes. Okay, so these sub processes will be decomposed into a next level. One point. Another point, that there must be the key concept between this is a balancing. Okay, balancing means that any input in a context diagram level. Note the point. Any input, let's suppose any input you have mentioned as a, and that is in the context diagram level, and when you are coming to the next level, this input must come to the next level. And if any input, let's suppose b, okay, at the context level, this must come to the next level. If these two input and output didn't come to the next level, then actually the next level is unbalanced. Okay, it here maybe few more inputs and few more outputs, but the two inputs which is in context diagram level, it may be 2, it may be 3, okay, that must come from context diagram level. Okay, let me show you through the diagram. Where was it? This one. If you see here, here we have three data. Okay, one is x, one is y, and one is z. So you see, from context diagram level, it go to level 0 diagram. Note the point, don't be confused. The context diagram has a number 0. The next level is called level 0, but its numbering is 1. Okay, its numbering is 1. Okay, the processes starts from 1. So how many processes you have? Let's suppose 3 processes. So process 1, process 2, process 3. It may be process 4, it may be process 5, or it may be only 2 processes. But you see, it must be more than 1. If it is not more than 1, then it's become the same context diagram, because context diagram has 1 process. So if the next level is also 1 process, so what's the difference? Okay, so it will be the numbering will start from 1, 2, 3. And my point of balancing was this. Balancing means, you see, x is in the context diagram level, x is there, so x is must be here also. Y is there, y must be here also. Z is there, z must be here also. Otherwise, if something is present at the beginning and disappear in next level, so why disappear? Okay, so it is not possible. Yeah, it is possible that some new inputs and outputs come in, like for example, the b is output for process 1, but it is input for process 2. Okay, the m, the n, and the a. So you see, at this level, the data, the number of data increase from 3 to 7. 1, 2, 3, 4, 5, 6, and 7. But the 3 must be there. So the 3xyz here, note this point, the 3xyz here, and the same it must be here. This is called balancing. Is it okay? Is it okay or not?
Yeah.
Okay, if is somehow clear, then come on to level 0 diagram. So you see, let's define once again, then maybe we'll be clear. Level 0 diagram shows all the major high level processes of the system, okay, and how they are interconnected. And level 0 diagram shows all the processes at the first level. The numbering, you see, the numbering start from 1, then 2, okay, starting from 1 actually. If there is another process, 2, third process, 3. The data stores and the external entities and the flow, and there must be balancing among them. Okay, ensuring that all information presented in the DFD at one level is accurately represented in the next level. So it's the definition of balancing, that whatever is in one level, it should go to the next level also. It is not possible that some input is available at one level and suddenly disappear in another level. Okay, so if disappear, this is missing of information, missing of data. It is not possible. Okay, so balancing means this one also. I already explained what is balancing. I think I should not read and should not explain again, but quickly like this, that if you look at this x, y and z, so it is already available here. One balancing, not only data, you see, not the point, even entity, you see, entity A is here, entity B is here, so you see entity A and entity B is here also. It is not possible that some entity just missing, no. Yeah, something can be increased. For example, data store can be increased. Here was no data store, here is, because this is a detail level. So in detail level, things can be increased but cannot be decreased, okay, and cannot be missing. This is called balancing. Okay, next level. Okay, so you will have to create a level 1 diagram for registration, course registration, and you will have to upload in the same way like this. Okay, next one, I think I have, yeah, level 1 diagram. The set of children and the parents are identical. They are simply different way of looking at the same thing. Yeah. Okay, it is important to ensure that level 0 and level 1 DFDs are balanced. Yeah, we are talking about this. All processes models have as many level 1 diagram as there are processes in the level 0 diagram. Okay, so in the level 0 diagram, oh, okay, it is like this. Level 1 diagram, what we do in level 1 diagram, in level 1 diagram and level 0 diagram, don't confuse the level 0 with context diagram. I am repeating the whole process about level 1 diagram once again. In level 1 diagram, what we do, we let's suppose we have three processes, 1, 2 and 3, right? So we pick up any one of these. For example, 2, we pick up one of these and explain further. And this is why it has a child and parent relationship. You see, child and parent relationship. So this is the parent process, which is 2. And now we are dividing this parent process into sub processes, and this is why its numbering starts 2.1, 2.2, 2.3. It shows that all these processes are actually children of process 2. And note the point that you see this process 2 has an input B. So you see the input B is still there, and this process B has another input M and one output N. So you see the input M and output N, these are still there. Okay, and the one output which was, you see here, that output A is also here. The rest of input and output, you see this output is extra, this output is extra, this output is extra, and this one is extra. And why these are extra? Because we decompose this into further sub processes, and these further sub processes, the siblings, they are siblings now. These siblings are connected through the data flow with each other, and this is why more data comes in, like K, H, G, C and Y. So level 1 diagram is like this, that we pick up one process from level 0 diagram and further explain, and the explanation is in the form of further decomposition, and the numbering, this is why, goes to the parent process. So let's suppose in this case we are using 2.1, 2.2, 2.3. If we pick up process 3, then the numbering will be how? Hello? If we
3.1, 3.2, 3.3.
Yes, very good. Then the numbering will be like this. And you see, for process 3, what will be the input and what will be the output?
A and Z.
Yes, you will must show here A, and you will must show the output somewhere. Okay. Sorry, sometime I cannot talk. So the output you will must show somewhere here. It is not necessary that you will must show from the first process or from the first child. So like in this case, you see the A is output from 2, but you see here the A is output from 2.3. Is it okay? So you see the same concept goes for level 2. You see level 1 and then level 2. The same concept comes to level 2 diagram or level 2 DFD. It is like this, that you will pick up one of the process from level 1. Like for example, in this case the 2.2, okay, we selected the 2.2, okay, for level 2 diagram, and this is why the numbering started from 2.2.1, 2.2.2 and 2.2.3. So the 2.2 is actually the parent level numbering, so you will keep that. The further decomposition will be 0.1, 0.2, 0.3. And now again to the 2.2, you see there are two, 1, 2, 3. Yeah, 3 are inputs, which are K, H and M. These inputs should be there. K, you see here the N, M are still there, and H, you see H is also there. But it is not necessary that everything will come to the same first process. No, because we decompose into 3, but it should be just balanced. Like K is here, K should be here. M is here, M is here. Okay, balancing means this level, okay, this level should be balanced with this whole level. Okay, but this may have more, but it is not possible that anyone is missing. So K is here, K is here, H is here, H is here, MN, MN are here. Okay, and then G and C are the output. You see G is the output and C is the output. Something come new, which are S and R and Q. It is possible because we are further decomposing. So what is it? The whole process we are just going through 4 levels, like context diagram, then level 0 diagram, then level 1 diagram, then level 2 diagram. Mostly when you go until level 2 diagram, then it is things become clear. But note one point. You see, in this case very important point, that we further decompose the level, the process 2. It doesn't mean that you leave the process 1 and process 3. In the same level, in the same way, there will be another level 1 diagram which decomposes process 3, but that will be called level 1 diagram. Note the point. And in the same way, there will be another diagram which is also called level 1 diagram, but that one will be decomposing the process 1. So this is, let's suppose, decomposing 1, and this is decomposing 3, and this one is decomposing the 2. So you see, all the processes will go to level 1 also. But in this case, just as an example, in this diagram we show only one, and this one is just example. It doesn't mean that you will not further explain this one and you will not further explain this one. If it is so simple process, let's suppose, if it is but you see, at zero level diagram it should not be simple. Okay, at zero level diagram we are actually still talking about very general level, a high level description. So it should not be that much simple, that doesn't need further decomposition. But it is possible that at level 1, one process is that much simple that doesn't need further decomposition. So meaning to say, let's suppose this process 2.2 go to level 2 for further decomposition, but maybe the 2.3 is already clear at this point. It doesn't need to go to level 2 diagram. Any confusion, any question? If I see hear some from your perspective, then maybe I will be able to explain. And now I don't know that you understood or not. Hello guys.
Yes, sir. Still processing.
Is clear or still processing? Clear, huh?
Yes, clear. I'm quite confused.
Oh, why? Sorry. Okay. No problem. It's you are right. I am 100% agree with you. If you are confused, it is possible. So where, at which point you are confused? Can you share with me? Because I was also confused when I was a student like you.
Starting from level 0, doctor.
Okay, yes.
That's where I got lost. Like initially I understand, but then I got lost.
Are you playing mobile also?
No,
Checking your Facebook status?
not at all.
Really?
Yeah.
Okay, so please be present minded. Okay, then you see, I'm explaining to you the whole process once again. Okay, uh, all of you, anyone who is not clear, I am going through the whole process once again, and hopefully I will try my best to be clear. Okay, so what is going on? We are doing like this, that the whole system, a very big system, even such a system like the whole universe. Okay, the whole universe you can represent as one process. Okay, so when you represent the whole big system as one process, this is called context diagram. So for example, if someone asks me that how you will present the whole universe process as a context diagram, then I will say like this, that students are getting knowledge from universe. So knowledge sharing system, on one side will be teachers, on the other side will be students. Teachers are sharing knowledge and students are trying to learn. So you see, the whole universe I combined into one process, and that process is what? Knowledge sharing. Is it okay?
Yes, sir.
Okay, good. So after this, After this, when we describe in one process like that, then actually this is one process we showed as one process, but actually it is not one process. We know that inside Unimass there is a hundreds and thousands of processes and systems are there. Okay, so let's decompose. So if we will decompose the whole system into high level decomposition again. For example, if we decompose the Unimass system into level 1, then what I can say, I can say like this, that let's suppose a finance system, all the payments, okay. So you see, it's the finance system is not only payment, there is a lot of things actually. The lecturer salary, the student fees, okay, the purchasing, the many things, the research grants and blah blah. So you see, finance is one thing, and then teaching and learning is another thing. And maybe let's suppose what should I say here, like okay, finance should be F. You can also help me. Finance, teaching and learning, okay, and learning. And next one should be what? Next one should be connectivity, like internet connections, okay, connectivity. So you see, finance, teaching and learning, and the connectivity system, I tried to explain the whole Unimass now in 3 processes, 1, 2, and 3. And these 3 processes are again very big processes. But I try to decompose into 3 big sections, okay. And this level is called level 0 diagram, and the numbering will start from 1, 2, and 3. This general division, again high level division, is called level 0 diagram. One aspect only. One aspect means that the one process here I further decompose into 3 processes. Is it okay?
Yes, doctor. Yeah.
Okay, this is one aspect. Another aspect is about data, uh, and that is balancing. Okay, balancing is very important, and I have shared one video on elip. That person is also explaining the balancing quite nice. Okay, maybe better than me, but okay. So what does balancing means? Balancing means that any data like x, y, and z which is available at context diagram, it will must go to level 0 diagram also. And this is why you can find x, y, and z here. This is another point about data. Third point about entity. Any entity at level at parent level, you can say like this, at higher level will must go to lower level, okay, or from 0 context diagram will go to level 0 diagram, like entity A and entity B. So you see, entity A and entity B are here, it cannot be missing, okay. Yeah, it is possible that new things, new informations comes in like data store. It is possible that new data comes in like B, A, M, and N. Okay, so three aspects: division of the one process into few further processes, one aspect; movement of data from context diagram to level 0, movement of entities from context diagram to level 0. Is it okay now? Level 0 diagram is clear?
Okay, doctor.
Okay, good. Are any confusion to anyone? Hello guys, anyone? Please don't reply to any WhatsApp messages now. Don't check your Instagram or Facebook status. Is it okay?
Understand, sir.
Okay. So now we are going from level 1 diagram to level 0 diagram to level 1. Don't confuse this 0 and this 0. Okay. Sometimes it's confusing. So now we are going from level 1 diagram to level 0 diagram to level 1 diagram. In level 1 diagram, what we do, that the processes that we decompose into level 0, like 1 and 2 and 3, we pick up one of this, okay, one of this, and divide that one into further processes. And this division is like a parent child division. Okay, this is why the numbering will follow. Like here is process 2, so the one child will be 2.1, another child will be 2.2, another child will be 2.3. So the main focus is that this process is again quite complex, and we want to decompose it into further sections. So the balancing will be again the same. Any input coming to this specific, not the point. Here our focus is not on the whole level. Our focus is only on this specific process 2. So any input to this process 2 and any output from this process 2 must be present here. Like to this process 2, input is B and output is Y, and another input is M, and another output is N, and one output is A. Is it okay?
Okay, sir.
Okay, can you tell me all the inputs to level 2, no, process 2? All inputs. Inputs to process 2.
E and M.
Sorry, I couldn't hear.
B and M.
B and M. Very good. Yeah, B and M. Okay, anyone else? All outputs? What?
A, Y, N.
Yes, good. A, Y, and N. So you see, yes, very good. So if we select the process 2, its name is process U, its number is 2. You see, every process has two components. One is number, one is its name. So when we pick up this one and go to level 1, okay, then it become 2.1, 2.2, 2.3. Okay, but you see all the input must be there. The B is here, the M is still here, the N is still here, okay, and the A will be in this whole level, but it is not necessary that it must be from this, okay, or it must be from this. You see, it should be as a output somewhere. Yeah, but some new things can come in because it is further detail. So when you are going into details, new things will come in. Okay, so the G, C, J, H, K, and Y, these no, Y is already there. Yeah, so these are new. Okay, so you see, we decompose the one process which is 2 and its name is process U into level 1. In the same way, this process 1 will be decomposed into another level 1 diagram. So you see, level 1 diagram will be several. Okay, the one process will be decomposed here, and the process 3 will also be decomposed in another level 1 diagram. So if you have 3 processes in level 0, then you will have 3 level 1 diagrams. Is it okay?
Yes, sir.
Okay, good. So then we are moving towards level 2 diagram. Okay, so if level 2 diagram, then is the same process as we did in level 1. We will pick up any one of these process. Okay, like in this case the 2.2 has been chosen for level 2 diagram. This is why the 2.2 is there everywhere, just is its children is 1, 2 and 3. Okay, so it is this one process is further decomposed into 3 processes, and all the input, output and the entities are keep balanced. So this process goes on. It doesn't mean that you will only go until level 2. If you want to decompose this process further, then you will go to level 3 diagram. Okay, and that level 3 diagram, what will be the processes numbers? Can anyone tell me? Let's suppose we want to divide into 3 processes, this one. Okay, into 3 processes, what will be the numbering?
2.2, 0.3, 0.1.
Yes, good. 2.2.3.1. Okay, next, and 2.2.3.2. okay, 2.2.3, this is the parent, and the second child 2, and 2.2.3.3, the third child. So in this way you will go. You see, this process actually depends on the complexity of the system. So you see, let's suppose, you see, this will be level 3. Okay, level 3 diagram. Let's suppose you want to further decompose this process again into 3 processes. Okay, so then again it will have level 4 diagram. Okay, level 4 diagram, and the numbering will be 2.3.3.1, and then oh sorry, I deleted everything. Okay, so I think you already understand what I am saying, right?
Yes, sir.
Yes, sir.
Okay, good. So
Sir,
yes,
sir, for the like we choose one of the process we want like sir, and then so each of the process when we want to go to another level, we take the output and input that goes from the process too kah?
yeah. The input and the output, you see, for example, you see like 2.2 here, right? So it has 2 inputs, one is H, one is K, one is M, third input. Okay, 3 input, and sorry, and 3 output, one is N, one is G, one is C, right? 3 input and 3 output. Is okay?
Yes.
Okay, the same thing you will find. You see, H is here as an input, K is here as an input, G is here as an output, C is here as an output, M is here as an input, N is here as an output. So these things make balance. You see, 3, which one is missing? K, H, M. Oh, yeah, is okay. So 6 data is here, the same 6 is there. So whatever is here, it must be here. But this may be something more. This will be 6 plus, like Q, R, and S. One aspect from data point of view. From entity point of view, you see, data store is here. This data store must be here. Okay, entities will go on, data and entity will go to next level, and it is possible that maybe you need another data store here. You can define, no issue. So is it clear now?
Yes, sir.
Okay, one
Yes,
question.
sir. Yeah.
Okay, good. We got one question. What if there's a process in process 3 also? Are they going to be two diagram? I didn't get properly. By process 3 you means which one? Can you unmute yourself? By process 3. Oh, here you means this one? Hello. Who asked this question? Oh, you mean this process 3. Okay. Yes, you are right. If you see here we pick up the 2 and it goes until level 2. In the same way the 3 will go until the same level. In the same way the 1 can go until 3 level. But not the point. There is but. The but is this, that let's suppose the level 3 came to this level but become very clear, then no need to go to level 2. At level 1 become clear, that's all. It is also possible, and it is also possible that this level 3, this process 3 go to level 1, then go to level 2, and it still need further decomposition, can go to level 4, can go to level 5, can go to level 6. But every process, not only 2, every process, the 2 will go to decomposition, 3 will go to decomposition, 1 will go to decomposition. Hi, is it clear?
Yes, sir. Understand.
Okay, good, very good questions. So if these are clear, okay, so let's go ahead, and I will skip now many things because I already explained. You see the level 2, level 3 process description. Okay, process description you can add. These are the some tools that, but this is beyond our scope. We will not go in further detail. This is the link I already showed to you. This is software to how to draw these things, but for this purpose I already share this link. Okay, you can use this one. Ignore this slide. Okay, so these are just instructions how to create context diagram. You see, build the context diagram, create DFD fragments for each use case. You see, actually to the data flow, the main input and the main idea comes from a use case diagram. You see, each use case diagram converts to context diagram, and then maybe context diagram is general, and each use case diagram become level 0 diagram, level 1 process. Another use case diagram level 0 level another process. Let's suppose this is 1, this is 2. Another level use case diagram become process 3. Okay, and then develop level 1 and level 2 and go on, but finally validate it. How to validate? Any idea how to validate?
No.
How to validate? By balancing. Okay, the way to validate is balancing. You go through that something should not be missing. Okay, This is one way of validation. There is some other ways also. Let's go to that one quickly. I am skipping this one because I already explained a lot. This is just example of another context diagram. I am skipping. Okay, this is the way to show you that, you see, this is a use case diagram. Okay, we have discussed this one in previous class also. So you see how use case diagram changes to one data flow diagram. Actually, all use cases will become a data flow diagram, because you see, from the course perspective, the requirements analysis comes to use case diagram. Okay, and the use case diagram comes to data flow, DFD. Okay, and then the DFD we will discuss in next lecture. It will become ERD. Okay, so this is a continuous analysis process. Okay, think like that. So this is another one, this is another one. I am skipping, right? Should not be an issue. The data store, the layout, you see how, where to put the data store, how to put it, is quite easy. I am very sure you can understand now. Level 1, what should be there. Level 2, yeah, I am skipping. Okay. Okay, so there are some mistakes. One is syntax error, one is semantic error. In programming perspective, syntax error is quite easy to understand. For example, if you, in programming, if you, let's suppose, forget semicolon, right? So you can easily find out what's the problem, or you misspell something. You can easily find out. So syntax error is quite easy. Logical error is actually quite difficult to find out, and quite difficult to fix it. And in case of analysis, semantic error comes from misunderstanding the discussion with client. When you are talking with the client, or when you are interviewing the client, or when you are designing the use case diagram, at that point you misunderstood the client demand. And once you misunderstood, your use case diagram will be wrong. And once your use case diagram is wrong, it will go to DFD. Your DFD will be wrong. So you see, that is actually a semantic error, and that one is very challenging issue to find out. So this is another two way of finding errors in your diagram. There are some other common things. I am skipping this process also. This is almost the same thing that we have done. Okay, these two rules, memorize it very well. Okay, these are very useful rules. Rule number 1, data at rest, okay, stays at rest. What does it mean? It means, let's suppose this is a ball, right? If it is staying here, it will stay until the end of time, unless someone or something push it, right? Are you understand what I am saying?
Yes, sir.
So okay, so the same thing is applying on data. Let's suppose data A will be data A unless this data A go into some process and process something and become something else, become B. If there is no process on this A, it cannot convert to something else. Okay, for example, you have ingredients of cake, okay, cocoa powder, sugar, blah blah blah. So if you don't process these ingredients, it will be ingredients for many years until you process it and it become a cake, right? So the same applies on data. So it means that data, any data, let's suppose A, B, C, X, okay, any data will be only converted to something else if there is a process involved. It is not possible, not the point, this is the point. It is not possible that without involving a process, a data A automatically converted to B. You see, here is no process involved and A become B. This is wrong. The first rule means this one. Is it okay? Hello?
Okay, sir.
Okay, good. Second rule. You should memorize this one. Second rule, process cannot consume or create data. It is like this. You see, that let's suppose this is a process. Okay, this is a process. It doesn't have any input and it give output. It's, let's suppose, a process P. Okay, process P create output, let's suppose output X, without having any input. This will be what? This will be miracle, right? Are you agree?
Yeah,
Yeah.
it's impossible.
Yeah, understandable, right? One case. What black hole means? You know the black hole concept? There is one. What is called?
Everything goes in.
Yeah. What's the name of the one black hole in a ocean? I forgot its name. That anything went there, never returned. Do you
The
remember?
triangle Bermuda.
Yeah, exactly that one. Yeah, that one. That anything once go there, okay, it will not return. Okay, it will not return. So it means what? In case of DFD diagram, it means like this, that there is a process. Okay, there is a process. It gets an input. Okay, it gets an input, but it didn't generate any output. Anything comes here disappearing. Anything come here and disappearing. It doesn't give any output. So this become a black hole. So it is a rule to check your DFD diagram, that if any violation of this rule, your diagram is wrong. If any violation of this rule, this is actually two part rule, black hole and miracle. Any violation of this rule, your diagram is wrong. And when we are checking your diagram, we are checking from this perspective. Okay, so this is another way to understand that my diagram is wrong or right. Okay, this process diagram show all the mistakes very nicely. You see, number one, all the numbers are mistake. In number one, what is the mistake? You read it, you see the input X, the input X is not going through any process and becoming output. So no process to move the data flow. It's like as I told you that the ball will be there if anything or it is I think Newton laws of motion, something like that. I forgot already. Physics. You remember that one? Okay, so this one, no process involved. Number two, what's the process in number two? Output has same name as input. You see, Z is going in and the same Z is going out. Is it possible? Sorry.
No, sir.
It is not possible. So if you do this type of mistake, it is wrong. Number third, what happens? You see, this data store is a miracle. It doesn't have any input and it's generating output. So the rule number 2 applies on this, the numerical one. Clear, huh? Number 4 is a black hole. Is a black hole. You see, black hole is like this, that input is coming to it and it doesn't generate any output. Ignore this part now. Okay, input is coming and no output is generating. So process 6 is a black hole. Here is what this is again miracle, that process 4 don't have any input and it's generating output. So without any input it's generating output. It's a miracle. Mistake number 6, this arrow is a bidirectional. It should not be, it is two-headed. It should not be two-headed. Mistake number 7, data store has no output. You see, data is coming from here and data is coming from here and it doesn't generate any output. So it is what? It is a black hole, right? This one,
Yes.
yeah, the number 8, you see, this entity is again going from this place to this place without any process. No process involved and it moves from one place to another, like the X. Is the same mistake like the X. So these are the ways to check your diagram. Any confusion here? Hello guys.
No, sir.
Okay, good. Okay, very good. You are good students. So let's go ahead then. Semantic error. Okay, one way to find out semantic error, that semantic error is like this, that at the end of the system actually you will get some strange result and then you don't know why this strange result is coming from where. You are not expecting that, or your client was not expecting that. Then you will have to go back, analyze, and the best way that you and your user and you or your client should walk through the system. And when you walk through the system, different level, at one point the client will tell you, oh no, actually I don't want this, I want this. So then you will find a point how to, where is the mistake come from. So that's all for today, and hopefully you understood